Good day, sir. I'm here to present my project, which is the heaps. In data structure, we already talked about linked list, ADT, sorting algorithms, and hashing. So for today's video, we are going to talk about heap. Hi, I am Joyd Columbus PWO. Welcome to CCE 105. In today's objective, we have determined what is heap, learn the process and operation of heap, determine the application of heap, sample implementation, heap visualization. So are you excited? So without further ado, let's go. Now let's define what is heap. What is heap? A heap is a special tree-based data structure in which this tree is a complete binary. Also, it's a kind of binary tree with properties. It's complete tree. All levels are completely filled except possibly the last level, and the last level has all keys as left as possible. This property of binary heap makes them suitable to be stored in an array. For example, if x is the parent node of y, then the value of x follows the specific order with respect to the value of y. And the same order will be followed across the tree. Take note that the maximum number of children of a node is in a heap depends on the type of heap. So, binary tree comes with two properties which are ordering property and the structural property. When we say ordering property, this refers to elements in the heap tree that are arranged in a specific order, which is divided into two types of heaps. We have the minimum heap and maximum heap. While structural property is known to be a complete binary tree, where it has all level completely filled except possibly the last level, which is here. We have here the first heap, maximum heap. So, a maximum heap is a complete binary tree in which each internal node's value is larger than or equal to the values of each children. It's simple to convert heap elements to array. If a node is stored at index k, its left child is stored at index 2k plus 1, and its right child is stored at 2k plus 2. We have here the operation of heap. Get max returns the max heap root element. Max heap maximum element is removed with help of extra max. Insert requires 0 login time. To insert a new key at the bottom of the tree, we add new key. We add a new key. We don't need to do anything if the key is smaller than its parent. Otherwise, we'll have to traverse up to fix the heap property violation. So, second heap is the minimum heap. Minimum heap is the inverse of maximum heap. If it's a binary tree such the data contained in each node is less than or equal to the data in that node's children. In other terms, the root node's k must be less than or equal to all of its children k's. For all subtrees of binary tree, the same property must be true recursively. The minimum k element is present at the root of a minimum heap. We have here the operation of minimum heap. Get mini, it returns the root element of many heap. Extract min removes the minimum element from the minimum heap. Inserting a new key takes 0 login time. We add a new key at the end of the tree. Delete. Deleting a key also takes 0 login time. We replace the key to be deleted with minimum infinite by calling decrease value of k. So, difference between stack and heap. Let's try to know what are the difference between stack and heap. So when we say stack, a linear data structure is a stack, but a hierarchical data structure is a heap. Stack memory will never become fragmented. However, heap memory will get fragmented as memory blocks are allocated and subsequently destroyed. Stack only allows you to access local variables, whereas heap allows you to access global variables. You can't resize stack variables, but you can resize heap variables. Heap memory is allocated in any random order, but stack memory is allocated in contiguous block. In stack, no deallocation is required, whereas heap deallocation is required. Compiler instruction handles stack allocation and deallocation, whereas the programmer handles heap allocation and deallocation. Now, let's move on to the application of heap. Priority queues can be efficiently implemented using binary heap. because it supports insert, delete, extract max, decrease k, operation in zero lagging time, binomial heap, and Fibonacci heap are variation of binary heap. This variation perform union also in zero lagging time, which is a zero operation in binary heap. Heap implemented priority queues are used in graph algorithms like Prim's algorithm and DJK-star algorithms. Order statistics. The heap data structure can be used to efficiently find the smallest or largest element in an array. So, sample code implementation. So, here are the sample code of the maximum heap and minimum heap. So, here we have the function to return the position of the parent for the node currently at pause, function to return the position of the left child for the node currently at pause, function to return the position of the right child for the node currently at pause, function that returns true if the pass node is a left node. So let's try to run this program. So we have here the value parent 3, left child 5, right child 6, parent 5, left child 9, right child 84, parent 6, left child 19, right child 17, parent 9, left child 22, right child 10. So the minimum value is 3. So let's try to run in a visualization. So we have here the minimum heap visualization. So as you can see, here are the smallest value, which is the 3, and his left child is 5 and his right child is 6, and then the second one is the parent 5, which is he have the child 9 and child 84, and the parent 6, he have the left child 19 and right child 17, and the last one is 9, you have left child 22 and right child 10. So this is the sample in visualization in minimum heap. So let's move to the maximum heap. So here are the code of maximum heap. So below two functions return left and right children. Construct initialize an empty max heap with given maximum capacity. So let's try to run this program. So here are the value of this program. The maximum heap is parent 84, left child 22, right child 19, parent 22, left child 17, right child 10, parent 19, left child 5, right child 6, parent 17, left child 3, right child 9. So the maximum value is 84. So let's try to run in visualization. So here are the maximum visualization. So this is the maximum. Wait. So let's try to edit this one. So now here are the root node, which is the 84, the bigger value. So his left child is 22 and his right child is 19, and the second parent is here you have left child 17, right child 10, and that parent 19 he have left child 5 and right side 6, and fourth parent is we have 17, the right child is left child is 3 and right child is 9. So these are the sample of visualization in maximum heap. So we already show what the heap visualization, the two heaps, which is the minimum and maximum heap. So that is the end of my presentation. Thank you.